I've included quite a long paper in the proceedings. For those that have had a look at it, it's like Mark Twain said, didn't have enough time to write you a short letter, so I wrote a long one instead. So it's a really extensive paper, but it's giving a kind of a hint about the research that is currently in progress. The second warning is this thing that I think Elia has tried to teach all of us. Thinking it can be very upsetting, right? And the warning at the bottom there, facts don't cease to exist because they are being ignored. We are sitting with something that is really fascinating from a TOC community perspective. On the one side, we've got exponential growth, both in organizations, both in the development of new technologies, but also in population growth. And this population growth is feeding the consumption that is allowing organizations to grow. But it's happening in a world of finite resources. And the question is, what does that equation look like? Exponential growth plus finite resources. Is it boom or bust? I was asked by the UN Development Program, a group of people that I trained in TOC, to write a paper. This was what triggered this initial research. Because I said that I couldn't find anywhere where it showed how TOC was being applied at a macroeconomic level. And surely that is where the biggest impact is required. To help more companies make more money is very good, but is it going to solve the world's problems? And that's really what triggered this presentation. So I'm going to just try to go relatively quickly through the key questions about why change, what's the problem, what's the extent of the problem. Are we starting to see signs that the problem is disappearing? Is it staying the same or is it getting worse? What's the cause of the problem? As soon as I started investigating this, I realized that there were a couple of mistakes, conceptual mistakes that we make. Many of you will recognize some of these. They relate, for example, to bad multitasking, to not understanding the consequences of starvation and blockage on throughput of systems because of interdependency and statistical fluctuations. But the one thing that I spend quite a bit of time on is trying to understand better the exponential function, and very quickly realized how few people actually understand it, and had the privilege of getting some really great minds to participate in this research. I'm then going to end up with, so what is it that we can change? Where should we be focusing on our skills? How can all of us help? And how should all of us help in this quest? So I love to start normally with this reminder from Eli in the beginning of the goal, in the forward of the goal. He says it's all about starting with looking for inconsistencies, not ignoring them, and then challenging basic assumptions. So let's start with that. What's the biggest inconsistency that we see in the world that we have today? And what are some of the basic assumptions that are kind of important to challenge? So, a better life for all. Really? Are we really leaving a better world behind? Something I know that all of us are passionate about. All of us kind of signed up to that, voluntary or involuntary, when we adopted TOC, right? And the question is that really the case? This vision is shared by some of the biggest moral leaders of our time, Mandela, Truman, and we have to do a kind of a reality check and say, is this really true? I come from South Africa. These are some of the clippings that you see in the newspapers. They might say, well, okay, that's in South Africa, but what about the rest of the world? And you find that when you look at the rest of the world, the news are not really any different. There are more and more scarcity crises happening around the world. They are happening in many different areas. There's shortage of capital, when capital is really needed to solve many of the problems. There's an increasing debt. Many people are questioning, is it really possible to recover from this? We have problems with water. We have problems with food scarcity. Many of these translate into significantly jeopardizing the vision that we have of a better life for all. So the question is, okay, but when we're dealing with any kind of resource scarcity, what we do is we can identify at least two types. There's the one type that is temporary. So something becomes a bottleneck. It kind of gives a shock to the system. We see early warnings about that happening, but we can find ways of overcoming. Then there's another class of resource constraint, which is finite. And this means that the only real way out is you have to find ways of squeezing more out of this thing to give yourself more time until you find an alternative. Because if you don't, the consequences are terrible. So let's have a look at some of the things that we know already, right? Many of you know this graph. It comes from queuing theory. It says if you've got a resource and the arrivals start approaching the capacity or the processing speed of that resource, you've got an exponential growth in queues. This is one of the most earliest warning signs that you've got that something is really becoming a constraint, that the queues start growing. So when you think about all the different types of elements where we start seeing queue growth, right? Think about road congestion. Think about the congestion. I travel a lot at airports. Think about poverty. Think about unemployment. All of these things is we should be asking ourselves a question, is a queue stable? Is it declining or is it growing? Of course, what happens when those queues grow and start exponentially growing, the reliability of your service of delivery also deteriorates, decays in an exponential way. And this is the thing that then triggers the vicious cycles of, I'm not sure exactly how much I'm going to get, because the last time I ordered, I got 50% of what I ordered, so I order more and it adds more load on an already strained system. Of course, one of the assumptions that we have to challenge that you'll see as a common thread right throughout is the simple assumption that we have more time. And one of the parts that make it very confusing for decision makers at all levels in companies and even at government level is at this point, you think you have a lot of time. Because it appears as if the growth is linear, right? And then suddenly there's this turning point and all hell breaks loose. I remember one of the companies I worked with for 5 years, they were supplying Toyota. They were consistently supplying within 4 weeks. 100% due date performance. One of the marketing directors went overseas and thought it would be good to get some additional orders. They added just 5% to their demand. Their lead time grew from 4 weeks to 12 weeks within 3 months. Just stepping over this little mark. We don't know exactly where this is. We know it's somewhere in the 80 to 90%. The good news, of course, is, and that's what we naturally do with TOC, the first thing that we do is we choke to release. We bring the system back into stability. We take it from this point back here. And you don't need much improvement to be able to do that. So this is kind of one of the signs that says we should be very careful in looking at these early warning signs. There's also something else called Little's Law, a diagram that I have used frequently for the last 10 years is something called cumulative flow diagrams. Very simple, you're just mapping the cumulative flow over time with a cumulative supply. So the red curve could be orders coming into the system in either dollars or tons or whatever unit you want to pick, and the green curve is showing those same orders being shipped out of the system. Of course, the horizontal line there is your lead time, supply lead time, the vertical line is your WIP. Very useful equation and very useful graph to understand why it takes so long for lead times to recover. As you can see there, if you've had a once-off increase in demand, even if it's only once-off, the lead times will permanently extend unless you have the capacity to catch up. The same thing is true if you've had a disruption in your supply. Unless you can find a way of catching up, the lead time will be permanently extended. These are things that within companies and within governments, we can use these techniques to provide us with very good early warning systems. Of course, we've got a real problem is where the demand is continuously growing and the supply is not continuously growing at the same rate or even declining. As I mentioned, these graphs can be used at any level in an organization simply by plotting cumulatively over time the demand for any specific product, resource, and in plotting what the delivery is, the shipments. This is the thing that scares all of us, because when those two lines cross, it's not good. I remember looking at a presentation that Ellie did, and he showed this almost similar graph and said what happens when the demand for health services crosses the budget that's available to provide those services. And when you think about it, so pick any of those and think about, are we close to that? Right? iPads is one that impacted me. What a mission to get one, right? I did some research, phoned a few friends of mine, and the statistics is quite damaging. I mean, Apple is selling these things at an incredible rate, but the research is showing that they've probably lost already a quarter of sales both on the iPad 1 and the iPad 2 because of unavailability. The demand is completely outstripped their forecast. And the forecast was close to what the capacity was. So you can add any one of those there. So these are things that I think that what we can teach the world is to say, guys, there are very simple early warning systems that you can be using. Please use them. Don't ignore them. Right? When you start seeing that queues are building up, take notice. When you start seeing that the queues are not going down, take notice. When they're starting to grow rapidly, really take notice. You've all played the dice game, right? This is one of the reasons why I think that we have many scarcity crises of resources. People simply don't understand the consequences of fluctuations and interdependency. We play the dice game. We say each of those resources on average can do about 3.5. You play it for 20 days. How much should you get out at the end? People guess and they say, well, if each of those can do about 3.5 per day, the whole system should get about 3.5 per day, and therefore, if we play it for 20 days, we should get about 70. And they are absolutely shocked when after the end of the game that they see they got out on average about 1.5 to 2 per day because of the starvation and the blockage. And when you look at the curve, you can see that's the real output over the 20 days, right? And you can see where it comes from. That's the individual outputs of the various resources. So whatever was the bottleneck that day, it governed the throughput of the whole system. Doesn't matter if all the latter 4 could have done 6 that day. If they only got 1, the whole system is crushed. This is true not just at the production level, but it's true at a macroeconomic level. What we do know is that the average output of a system will always be less than the capacity of the constraint or the bottleneck. But there's a huge potential to increase it if we can just find ways to make sure that the constraint is never blocked or starved. Something that we use with this game that's kind of counterintuitive. We ask people, okay, so play the game. They get about 50 or 35 compared to the 70. We really bash them up a little bit and say that your managers and shareholders will not be very impressed. So what are you going to do? And they figure out, well, maybe what we can do is we can allow some WIP to build up. So let's put a Kanban of 1 in between each of those to try and decouple a little bit from the starvation and blockage. And they get some benefit. The throughput will go up to around 40, 45. And we asked them, so what else can you do? Do you think it's possible to significantly improve if you don't have money? And they come up with all sorts of solutions, but most of them will take long or they will cost money. And we simply asked them to do 2 things, very counterintuitive. The one is, rather than trying to protect each of the resources with 1, take the 4 that you've got the buffer and put it all in front of C. And they do something that's really counterintuitive and slow down C. How do we slow it down? We take away the chances that there's a 6. So we reduce the average from 3.5 to 3. So what do you think should happen? You reduce the capacity of the potential capacity of the bottleneck. We should expect that the throughput should go down. It goes up. Right? We've taken the thing out of chaos. We've protected it properly. And suddenly they're getting very close to 60, which is really what the real potential of the system is, without spending significantly more money. So simple things that we can do. We've talked about in the previous 2 days, for those that have been here, about the key lessons from bad multitasking. Initially, we thought that the major problem is just that we're losing setups, right? We thought that that was the major problem of bad multitasking. When you have integration tasks, you not only lose the setups, you also lose the synchronization. A helicopter